Okay, welcome back. We're about ready to actually make this thing do something. So I'm going to hit the little VCR stop thing to make that go away. And now we're actually going to go in here and call the method that we wrote. So first I need to be able to assign a value to the target. How about 42 is a good starting number? Cool. All right. And then I want to do the call that method. So I'm going to say index is equal to sequential search. I want to pass it my list, my target, and the value for n, which is the maximum number. Okay, so now I've actually done the search, but now I need to figure out, well, show me that the dang thing worked. So I need to put in another console kind of a thing. So console write line, and I'm going to say, you know, searching for target found at, oops, index. Okay, so what this does is basically says, what were you looking for and where did you find it? Now, it could be that it's going to find it immediately, right? It could be that it's not going to be there at all. So let's just run this thing one more time. Searching for 42 and found it at 66. Cool. Now, if I run it over a second time, is it going to come up with the same answer? No. Now it's at 40. Right? Because every time I run this, I get a new batch. Oh, here's where it wasn't found at all. So 42 wasn't in there at all. Okay. So this is a pattern that you're going to have to learn on how to put these things together. Now that we got it operational, then we need to move on to instrumentation. Now, the instrumentation that I'm asking for is not something that's in the book at all, okay? So you have no choice but to pay attention. So what we're going to do is we're going to go in and do two types of instrumentation. A very simple one would be to calculate the loops, how many loops it takes to do something, okay? So I'm going to go up to the top and build me another one of those field variables, like here, and I'm going to say static int loop count equals 0. Well, yeah, okay, fine. So now I have a loop count. Okay. All right, so let's just start. So now that I got this, where do I count the loops? If I go down to here, if I put my loop count right there, okay? If I did that, what would be the result? Well, the result would be that every single time, well, that's a bad example. Dang. If I put my loop count right here, then every time this thing runs, it's going to count the number of loops. I would prefer to put the loop count inside the if statement. In this particular case, it doesn't really matter, but it makes a little bit more sense in some other context. So I'm just going to go in here and say loop count is equal to loop count. Now, do I want to count the number of loops like this, like 1? Is that the way I want to do this? So it's been through just one time? Well, no, that's not going to work. So what I want to do is I want to put it up here and say, okay, now my loop count is going to count, and then whenever you get the heck out of the loop, obviously the loop counting will not happen. But what happens if you get down to here? I really kind of need to increment it one more time. So if you did not find it, I need to actually include the fact that you didn't find it. So I'm going to increment my loop count one more time. Okay, so now I've got a loop count. Okay, so let's go up to here and let's put in the loop count. So I'm going to say console write line loop count is okay. Helps if you spell it right, but that's okay. All right, let's check this out, see if it works. Okay, so loop count is 101 because we didn't find it. That's a good answer. Let's do it again. So loop count is 13, and we found it at 12. So it turns out that the loop count and the ID are actually really the same thing, aren't they? Right? Kind of, sort of. So I could shortcut this a little bit, okay? Rather than spending, because I don't want my instrumentation to consume resources. In other words, the thing you're measuring, like if you're trying to measure voltage, if the meter itself drops the voltage when you start to measure something, that's bad. So instead of putting the loop count like that, I'm going to just cut to the chase. Now that I figured out how this dang thing works, I'm going to say loop count is equal to I. And that way, the loop count only happens once rather than over and over again. And here, I'm going to say max plus 1. Okay? That way, the loop count itself isn't interfering with the thing. Now, it's not going to make any changes. It's still going to come out the same, see? It's just that do you see what I've done? I've reduced the burden of the instrumentation by understanding how the instrumentation works. I figure out that the loop count can only happen in 2 locations, and therefore it's not going to consume much energy. Okay. So the next thing we're going to do is we're going to create a stopwatch and then see how long it takes to do this. Now, I have a stopwatch feature that you may not have, and so for example, the Java folks are going to have to download one, and I'll put some links in the sample file that explain where to get that thing. So I'm going to go in here and just say stopwatch SW is equal to new stopwatch, like this. Of course, it's going to complain and say, what the heck are you talking about? But if I hover over that, it's going to say, oh, would you like me to implement this or get this guy? So, dang it, helps if you spell things correct. So what it is, it added an extra little using statement, okay? So an include statement, depending on what language you're in. So what I'm going to do now is right immediately before, I'm going to say SW start. Okay? And then immediately after that, I'm going to say SW stop. So as soon as when I get down to the thing, in other words, I do not want to be measuring how long does it take to fill this thing full of random numbers. That's not part of my exam. How long does it take to spit out things? No, that's not part of what we're trying to examine. We're trying to examine the sequential search guy. And so I put the start and the stop immediately afterwards. Now, Javanauts, you're going to have a little different trouble. You're going to have to do well, in this case, you can use start and stop, but pretty soon we're going to use pause and resume. So now I got the loop count. So now I want to figure out what is the time. So I'm going to say console write line and say something like, I don't know, milliseconds is okay, and I'm going to do SW, and then SW has some really cool things. It has a way that you can spit out like the elapsed number of milliseconds in my world. In your world, it might be slightly different. So I got elapsed milliseconds. Actually, this sounds a little weird. I'm going to use this other one, elapsed dot milliseconds. And then, so that will tell me how long this thing ran. Okay, cool. Now let's go run this guy to see what happens. Okay, so I'm searching for 42. I found it at 53. The loop count is 53. I was expecting that. And the number of milliseconds is 0.1. Okay, that sounds reasonable, right? Now, unfortunately, just taking one sample is almost never a good idea. So one of the things I'm going to do is I'm going to do a sample 10 times. So I'm going to go back up to here and do me another, let's do it as a constant, just for the heck of it. I'm going to do constant integer tries equals 10, which means I'm going to run this thing 10 times. And then take the average of the execution time and average of the loop count, right? Doesn't that sound a little better than just doing it one time? Okay. So I don't want to do the loop anything other than right here. So I'm going to do a for loop. So I don't know. I can use I again. I'm going to use t for is 0. T is less than tries t plus plus. Okay. So now I'm still going to keep the start and the stop just the way it is. Okay. Except now I'm running it 10 times. So the loop count now has to be divided by okay. Loop count needs to be divided by 10, right? Like this. And the total milliseconds really needs to be divided by 10 to make this work, right? I tell you what. Yeah, let me go ahead and do that. I'm going to go ahead and, yeah. So, because not 10, I'm going to use the constant tries. Sorry. My brain was fried there for a second. Okay. Well, now I've kind of sort of got a problem because I still want to be able to see the target that we're looking for. So I want to put this inside the loop. But I do not want to put it inside the timer. Okay? You see why I did that? In other words, I do not want to measure how long it takes to spit out searching for on the screen. That's not part of what we're instrumenting. We're supposed to be instrumenting how well this thing works. Okay? So the stopwatch should only be running while we're doing the search. No overhead and no display, none of that stuff. Which means you can't have a console write line inside this guy anywhere because that'll mess up the time. So you might think, okay, we got this. Well, let's run it and see what happens. And so, searching for 42, wait a minute, that's pretty dumb. I probably need to come up with a different thing I'm searching for now, rather than just a constant, right? Because finding it over and over again really wasn't what I had in mind. So I need to come up with a new target. But once again, I'm not going to put this part I'm generating now, I'm not going to put that inside the stopwatch. So I'm going to say target is equal to, I'm going to use the exact same thing we did before, which would be dext. And I'm going to do 1 and n plus 1. Okay, I can comment this guy out now because I don't actually need it. So now it's going to be doing 10 runs, but with random numbers. If I want this thing to make any sense, this is the way it's going to have to work. So now we got something, right? We're looking for this and found it, looking for this and found it. We're looking, the loop count is 6, and then the number of milliseconds is whatever. Hey, I don't like the fact that this came out as an integer. I probably need to change something. So I'm going to change my loop. I'm going to do what's called a cast. I'm going to cast this to a double. Casting for a double means it won't round off the numbers. Okay, let's go do this one more time. So now the loop count is, some other number. Okay. Now, is this making sense, you guys? I hope it's making a little bit of sense. Okay, we're coming up on the 15-minute mark.